Uranus and Neptune are somewhat of a mystery because in a way, they shouldn't exist, or at least they shouldn't exist where they are.
The James Webb Space Telescope has beamed back a breathtaking image, revealing the icy giant in stunning detail, the best we've seen in 30 years. But hold on, this isn't just a pretty picture.
Out where Uranus and Neptune are, tons of ice, tons of frozen gases as we might think of them, methane, ammonia, water. And so that's what makes up their composition predominantly.
This new view can tell us more about what's beneath Neptune's stunning blue surface. As one of the least explored planets in our solar system,
as you move further out in the solar system, the time scale for two bodies to find each other and collide and accrete slows down because the periods around the sun are much longer. It just takes a very, very long time.
Neptune is a world full of mysteries waiting to be figured out. Prepare to be surprised. We're about to dive into what the Webb telescope has revealed and why Neptune might be more fascinating than ever imagined. James Webb's image of Neptune. For over 3 decades, our best glimpse of Neptune remained a single image captured by the Voyager 2 spacecraft in 1989. Launched in 1977, Voyager 2's mission wasn't solely focused on Neptune. It was designed to explore the entire solar system and eventually depart into interstellar space. While the Hubble Space Telescope also offered some views of the distant ice giant, the detail wasn't enough to satisfy the scientific community's thirst for knowledge. All of that changed with the highly anticipated launch of the James Webb Telescope, JWST, in 2021. September 2022 marked a turning point in Neptune's story. The JWST not only delivered the clearest picture of its rings in over 30 years, but also revealed the planet itself in a completely new light. This revolutionary view was captured by the NIRCom instrument, which operates in the near-infrared range, invisible to human eyes. In these wavelengths, Neptune appears remarkably dark, a stark contrast to its familiar blue hue. This darkness is likely due to methane gas, which strongly absorbs red and infrared light. Compared to the gas giants, Jupiter and Saturn, Neptune is much richer in elements heavier than hydrogen and helium. However, the image isn't devoid of brightness. The contrasting bright stripes and spots are actually high-altitude clouds composed of methane ice, reflecting sunlight and appearing almost white in the NIRCam image. This technique, alongside the superior resolution of JWST, allowed for the first clear view of Neptune's fine ring system, which scientists suspect are made of ice crystals. While these rings were known from Voyager 2, previous technology struggled to capture their details. Another interesting feature revealed by the JWST image is a thin, bright line encircling Neptune's equator. This line is a telltale sign of powerful atmospheric circulations, essentially violent winds and storms raging on the planet's surface. The image also provides a clearer view of a previously known vortex at the South Pole, and for the first time, depicts a continuous band of clouds enveloping Neptune at higher latitudes. These advancements in observation technology allow scientists on Earth to utilize light-filtering methods and remotely determine the composition of gases and other structures on Neptune. Studying the rings alone, first observed by Voyager 2, promises exciting new insights into the composition of this distant ice giant. For astronomers, the JWST observations represent a major milestone in Neptune research and a long-awaited breakthrough, especially considering the lack of funding for a dedicated Neptune probe mission at present. The new data from JWST offers a wealth of information, unveiling previously unknown details about the planet's atmosphere, rings, and weather systems. About Neptune, the most mysterious planet in the solar system. This icy giant, bathed in an ethereal blue glow, orbits the sun at a mind-boggling distance of 2.8 billion miles. That's over 30 times farther than our planet. Since Pluto's reclassification in 2006, Neptune also holds the title of farthest measured planet. The 8th planet in our solar system, Neptune also boasts an impressive size. It's the 4th largest planet and the 3rd most massive, packing about 17 times Earth's mass. Interestingly, it's even slightly heavier than its icy twin, Uranus. Speaking of ice, Neptune's primarily made up of gases, liquids, and, you guessed it, ice. This composition earns it the official title of an ice giant. It takes a slow 164.8 Earth years to complete one orbit around the sun, so patience is definitely a virtue on Neptune. A discovery written in the stars. Believe it or not, Neptune has the distinction of being the first planet discovered through pure math. For decades, astronomers scratched their heads at the peculiar wobble in Uranus's orbit, discovered in 1781. It hinted at the gravitational tug of an unseen celestial body. While Galileo Galilei spotted a curious blue blur in the 17th century, he mistook it for a star. Fast forward to 1846, and British mathematician John Couch Adams used calculations to predict the existence of another planet beyond Uranus. French astronomer Urbain Le Verrier independently reached the same conclusion around the same time. It wasn't until German astronomer Johann Gottfried Galle finally spotted the elusive Neptune in the night sky on September 23, 1846, confirming their predictions. Neptune's most striking feature is its vibrant blue color, of course. This mesmerizing hue is caused by the methane gas that makes up a large portion of its atmosphere. The way methane molecules vibrate absorbs red light, leaving the blue wavelengths to dominate the reflected light we see. This celestial blue beauty even inspired its namesake, the Roman god of the sea. Despite its captivating appearance, Neptune remains one of the least explored planets in our solar system. Over the past few decades, scientists have observed dramatic changes in its atmosphere, raising concerns. With limited data, researchers are left scrambling to understand these mysterious shifts. The Great Dark Spot. Neptune holds a few fascinating mysteries, and its weather is definitely one of them. Back in 1989, Voyager 2 flew by the planet and spotted a giant swirling storm, the Great Dark Spot, in Neptune's south, eerily similar to Jupiter's Great Red Spot. But there's a strange thing about this spot. Just a few years later in 1994, a team of scientists using the Hubble Space Telescope peered at Neptune again, and the Great Dark Spot was gone. In its place, a brand new dark spot placed in the north. This dark spot must have formed between Voyager flyby and the Hubble photos. Since then, Hubble has discovered several more black spots. They develop at mid-latitudes in both hemispheres and tend to move in the direction of the equator, but they face certain death if they do that. This disappearance revealed a key difference between Neptune and Jupiter's storms. Unlike Jupiter's Great Red Spot, which has raged for centuries, Neptune's storms are short-lived. They might not last, but they sure do pack a punch. Neptune reigns supreme when it comes to wind speeds. These ferocious storms can whip around at a mind-blowing 1,305 miles per hour. To put that in perspective, the most powerful hurricanes on Earth manage a measly 186 miles per hour. So yeah, getting caught in a Neptune storm wouldn't be ideal. Unexplainable processes on Neptune's surface. Neptune keeps scientists on their toes, especially when it comes to its weather. In 2018, researchers spotted a monstrous storm raging in the planet's north. The giant swirling storm on Neptune was bigger than the entire continental US. They tracked it for years, expecting it to follow the usual path south towards the equator, where Neptune's storms tend to vanish. This happens because of a special weather phenomenon. Our planet's rotation creates the Coriolis effect. This fancy term basically means winds moving at different speeds depending on where they are on the planet. Think of a merry-go-round. Things at the edge move faster than things closer to the center. The Coriolis effect acts like an invisible hand, steering winds and shaping storms. On Neptune, storms born near the poles get nudged by the Coriolis effect as they travel south. As they get closer to the equator, this influence weakens, causing the storms to break apart and disappear. But this monster storm in 2018 defied expectations. It defied the Coriolis effect and kept chugging south. That's what makes it so mysterious. But 2020 brought a surprise. Hubble captured the storm doing a U-turn, heading back north. This unprecedented behavior left researchers baffled. Scientists have tracked similar dark spots for nearly 30 years, but this was something new. Was it a rare anomaly or something more? Adding to the mystery, Hubble has observed other dark spots disappearing and reappearing over the years. The largest storm Hubble has ever observed on Neptune was 4,600 miles in diameter. Researchers have been observing the behavior of the storm since 1993, and they noticed that the storm seemed to disappear several times, perhaps actually dissipating, only to reappear not far from where it disappeared. One theory suggests these storms might hide in Neptune's deeper atmosphere before resurfacing. Perhaps the storms disappear only superficially, but continue to rage in the deeper layers of Neptune. From time to time, the events could then become visible again on the surface. Unfortunately, we lack data on what's happening down there. The storm continues to surprise. But it doesn't stop there. This storm's about to get even weirder. Just as it defied expectations and reversed course, it appears to have given birth to a smaller companion storm, like a miniature version of itself. This isn't entirely unexpected. Some computer models predict that as giant storms on Neptune weaken near the equator, they might shed smaller whirlwinds. We couldn't directly observe this happening due to limited data, but it's a strong possibility. Maybe shedding this mini-storm helped it change direction, some scientists theorize. Another oddity is that unlike most dark storms, this one lacks the usual bright white fringe. These are methane ice clouds, super reflective and appearing white in images. Normally, winds carry methane gas up the storm's high-pressure center. Think of a giant mound of air, where it cools and crystallizes into ice clouds. Here on Earth, mountains create similar orographic clouds, when moist air rises, cools, and condenses. We saw these white clouds on Neptune in 2019, but they vanished in 2020. Could this be linked to the storm's strange behavior? Maybe, maybe not. Studying Neptune is tough. It's incredibly far away, appears tiny in our telescopes, and its atmosphere changes rapidly. It's high time we explore Neptune. The answer might lie in a future mission to Neptune. Similar to Cassini's plunge into Saturn, a probe could dive into Neptune's atmosphere, collecting crucial data. This is still a dream, but Neptune's turn for a dedicated probe seems likely. This mission might even have an exciting bonus: the hunt for Planet X. Since Pluto's reclassification, Neptune is the solar system's last major planet. However, wobbly orbits of some objects hint at a hidden giant, Planet X. Lurking far beyond Neptune, Planet X or Planet 9 could have a highly elliptical orbit, taking thousands of years to circle the Sun and remaining invisible under current observation conditions. It might only become a blip on our telescopes every few hundred years. Will a future Neptune mission unveil the secrets of its stormy atmosphere and nab the elusive Planet X? Only time and powerful telescopes will tell. Neptune's largest moon, Triton. James Webb's stunning image of Neptune might have left you wondering about that brilliant blue-green light in the background. Fear not, it's not an alien beacon. That eye-catching sparkle is actually Triton, Neptune's largest moon, and the brightest of the moons captured in the image. Roughly the size of our own moon, Triton stands out with its greenish hue. This unique color is a result of the image's special filters, but it also reflects how Triton bathes in the faint sunlight reaching its distant orbit. But unlike most moons, Triton has a smooth, icy surface with barely any craters. Here's where things get interesting. Scientists believe Triton might not always have been Neptune's companion. Its oddly elliptical orbit suggests it could have been a wandering object from the Kuiper Belt, eventually stolen by Neptune's gravity. This theory gets even more interesting because Triton travels around Neptune in the opposite direction of the planet's rotation, a big clue that something dramatic happened in the past. But Triton holds even more intrigue. Just like Jupiter's Europa and Saturn's Enceladus, Triton shows signs of ice volcanism, hinting at a possible ocean beneath its icy crust. This possibility makes Neptune and its moons a prime target for future exploration. Triton is a world with a potential ocean and a mysterious past. Its orbit and structure is one of a kind. Until then, we eagerly await the next surprise James Webb has in store for us: JWST, Neptune, rings, and its various moons. Thankfully, space exploration isn't standing still. The incredible images taken by the James Webb Space Telescope, JWST, are helping us piece together the story of Neptune and its 14 incredible moons. Most of these moons are on the smaller side, under 200 kilometers wide, and a bit on the irregular shape side. Think more lumpy potatoes than perfect spheres. One exception is Proteus, which clocks in at a respectable 400 kilometers across. Now, some of these moons are hanging out right in Neptune's rings. These are called the Shepherd moons, named after astronomer Alan Shepard. Scientists think the gravity of Despina and Galatea, two of these moons, might actually be helping to clump the ring particles together into those distinct bands we see. Pretty cool, right? But Triton is a real heavyweight in the world of moons. This isn't your average moon. It defies expectations by orbiting Neptune in a backward motion, meaning it travels in the opposite direction of the planet's rotation. Their leading theory is that Triton wasn't always Neptune's companion. As mentioned earlier, they believe it might have originated in the distant Kuiper Belt, a vast region beyond Neptune filled with icy objects. Millions or even billions of years ago, Neptune's powerful gravity might have snagged this sizable object, turning it into its largest moon. However, the exact details of this cosmic capture remain shrouded in mystery. Scientists are eager to learn more about the forces that could have orchestrated such a dramatic event. Clocking in at a whopping 2,700 kilometers wide, it just barely edges out our own moon in size, 2,159 kilometers. In fact, Triton is even larger than Pluto, the former ninth planet, which comes in at a mere 2,376 kilometers. But what really makes Triton stand out is its captivating teal color. This vibrant hue isn't just a quirk of the JWST's filters. It's all thanks to a thick layer of frozen nitrogen blanketing Triton's surface. Frozen nitrogen is a highly reflective material, which means it bounces back a lot of light, especially in the blue and green wavelengths. This explains why Triton appears so much brighter than the distant gas giant Neptune itself. However, you might be wondering why we don't see these diffraction spikes around other large objects in JWST images. The answer lies in the size of the light source. These spikes are an artifact of how light bends around the JWST's structure, particularly the three supports holding the secondary mirror and the hexagonal shape of the primary mirror segments. When the light source is large, like Neptune, the spikes get smeared out across the entire object, becoming faint and difficult to discern. But with a small, compact source like Triton, the diffraction spikes become much more prominent. They appear like sharp lines radiating outwards from the center of the moon, almost like a tiny blue starburst. This unique combination of size, composition, and telescope design has given us a truly remarkable view of Triton, offering astronomers a wealth of new information about this fascinating moon. Unveiling Neptune's secrets, its atmosphere. The JWST images also offer a breathtaking close-up view of Neptune's atmosphere. Beyond the swirling blue clouds and the intricate ring system, we can see hints of fainter rings, some so delicate they appear as mere wisps. But one particularly intriguing feature stands out. A very thin, faint line circling the planet solely around its equator. This line might hold the key to understanding a fundamental difference between Neptune and our own planet. Unlike Earth, where atmospheric circulation tends to move from the equator towards the poles, Neptune's atmosphere exhibits the opposite behavior. Gases travel from the poles towards the equator, where they sink and warm up. The faint line observed by JWST could be evidence of this warm rising gas emitting infrared light. This unique atmospheric circulation pattern contributes to Neptune's extreme weather systems, with winds reaching speeds of up to 2,100 kilometers per hour, the fastest in our solar system. Understanding how this circulation works will be crucial for unlocking the secrets of Neptune's climate and its dynamic atmosphere. Neptune's bright blue color. While space probes regularly beam back stunning images of Jupiter's swirling storms and rovers trundle across the dusty Martian plains, Neptune remains a distant, enigmatic world. Unlike Saturn, which hosted the Cassini spacecraft for a record-breaking 13 years, Neptune hasn't had a dedicated visitor. Recently, a new study unveiled the secret behind Neptune's vibrant blue color, briefly thrusting the distant planet into the spotlight. However, the lead author, Dr. Patrick Irwin of Oxford University, admits the discovery was an unexpected bonus. Their focus was on both ice giants' atmospheres. Dr. Irwin's team wasn't specifically seeking the answer to Neptune's stunning blue color. Their primary focus was on the atmospheres of both Neptune and Uranus. These ice giants, as they're called because scientists believe they formed from icy materials, are often studied together. Roughly Earth-sized but dwarfed by Jupiter and Saturn, they share many characteristics. Both ice giants lack solid surfaces and boast atmospheres dominated by hydrogen, helium, and a touch of methane. Scientists even suspect these atmospheres harbor a bizarre phenomenon, diamond rain. Under the immense pressure deep within, carbon atoms might be squeezed into the precious gems. Previously, researchers knew that methane in these atmospheres played a key role in their blue color. It acts like a cosmic filter, absorbing red sunlight and leaving shades of blue and green for our telescopes to detect. However, Dr. Irwin's team was about to make an unexpected discovery that would shed new light on this phenomenon. Dr. Irwin's team stumbled upon a fascinating clue. A layer of methane haze in Uranus's atmosphere was twice as thick as Neptune's. Without this haze, Dr. Irwin explained, both planets would naturally appear a vibrant blue. The haze acts like a cosmic dimmer switch, muting the color intensity. The scientists theorize that Neptune's more turbulent atmosphere is better at churning up methane particles, thinning out this haze layer. As a result, Neptune shines a deeper, richer blue compared to Uranus's gentle aquamarine. This difference makes them a captivating contrast, highlighting the unique characteristics of these underappreciated ice giants. Neptune, theoretically, holds the title of the farthest planet from the Sun, but will it also claim the crown for the bluest? Why Neptune deserves special attention right now? The debate surrounding Pluto's planetary status refuses to die down, even after its demotion in 2006. But planetary scientists have their sights set beyond this celestial controversy. They're hunting for a hypothetical Planet X, a giant world theorized to lurk beyond Neptune, its gravity potentially influencing the unusual orbits of some distant objects. If, as many scientists recommend, NASA prioritizes a mission to Uranus in the coming decade, Neptune will become the only planet in our solar system unexplored by a dedicated spacecraft. This would be a missed opportunity, considering Neptune's unique history and mysteries. NASA's Voyager 2 became the first and only spacecraft to visit Neptune in 1989. During its grand tour of the outer solar system, Voyager 2 whizzed past this distant blue giant, its moons, and even its surprisingly intricate rings. While not as spectacular as Saturn's iconic rings, Neptune's rings showcase the wonders lurking in the farthest reaches of our solar system. Since Voyager 2's groundbreaking flyby in 1989, no spacecraft has ventured near Neptune. Planetary scientists face a difficult choice: prioritize a mission to the closer Uranus, or tackle the immense challenge of reaching the distant, enigmatic Neptune. While a dedicated Uranus mission in the early 2030 could offer valuable insights into both ice giants, it wouldn't do justice to Neptune's unique story. Though sadly, its incredible 165-year orbit around the Sun, compared to Uranus's 84 years, makes exploration a logistical hurdle. Mission to orbit Neptune. The recent James Webb Space Telescope, JWST images, have reignited scientific interest in Neptune, the distant blue giant at the edge of our solar system. While these observations offer tantalizing glimpses, they highlight the critical need for a dedicated mission to truly unlock Neptune's secrets. The ideal approach to studying a planet is a long-term orbiter mission, just like the success story of Cassini with Saturn. Such a mission allows scientists to witness the dynamic nature of the planet. Features evolve, weather patterns shift, and most importantly, unexpected discoveries can be followed up on in real time. Cassini's mission, for instance, yielded a wealth of information as researchers adapted their observations to investigate newly discovered phenomena. While initial flybys, like Voyager's historic encounter with Neptune, provide a first look, they lack the depth needed for comprehensive understanding. The dark storms observed on Neptune during the Voyager flyby were a groundbreaking discovery, but unraveling their origins and dynamics requires sustained study. The key lies in repeated observations and the ability to adjust exploration plans based on new findings. Unfortunately, a human mission to Neptune is out of the question for the foreseeable future. However, a dedicated spacecraft designed specifically for Neptune exploration would be a game changer. The JWST offers invaluable observations, but it cannot replace the power of an orbiting probe. The challenge lies in the fact that mission proposals for a Neptune orbiter, like the one with a potential launch in 2033 and arrival in 2049, face a crucial decision. Prioritizing Uranus as a first stop could delay Neptune exploration by at least a decade. This means Neptune, the bluest planet in our solar system, might have to wait until well into the 2050s to have a dedicated spacecraft companion. The wait for Neptune may be long, but the scientific rewards promise to be immense. Understanding Neptune's unique atmospheric circulation, the composition of its moons like the enigmatic Triton, and the nature of its extreme weather systems are just a few of the mysteries waiting to be solved. Hopefully, a dedicated mission will finally embark on this long journey, revealing the hidden wonders of the solar system's most distant giant. Discovery of a mini Neptune? Astronomers have spent years scratching their heads over a puzzling, cloud-enshrouded planet orbiting a distant star. This mini Neptune, called GJ 1214b, defies easy categorization. Unlike anything found in our own solar system, it falls between the size of rocky planets like Earth and the gas giants like Jupiter and Neptune. But the recent James Webb Space Telescope observations have shed new light on this enigmatic world, revealing a surprising twist. It's cooler and shinier than expected. GJ 1214b's unique size class has scientists intrigued. Is it a scaled-up Earth, a scaled-down Neptune, or something entirely different? Perhaps a water world dominated by a steamy atmosphere. Its relative proximity, just 48 light-years away, makes it a prime candidate for study, but its thick cloud cover has long been a barrier to understanding its composition. Traditional methods like observing the planet transit its star and analyzing the filtered starlight proved ineffective. However, the James Webb Space Telescope, with its ability to detect infrared light, that is its heat, offered a new perspective. According to Elizabeth Kempton, lead author of the study published in Nature, the planet has been a challenge for astronomers. They've been trying to understand the composition of its atmosphere for a long time. The Webb telescope observed GJ 1214b as it orbits its star, mapping out its temperature across different phases of its day-night cycle. Surprisingly, the dayside temperature reached a scorching 530 degrees Fahrenheit, too hot for any known life, but significantly lower than scientists anticipated. This temperature discrepancy suggests a highly reflective planet, scattering back a significant portion, around half, of the incoming stellar energy. Previous theories suggested the clouds might be composed of a dark, sooty haze, but this new data shoots down this idea. The James Webb Space Telescope observations have opened a new chapter in our understanding of GJ 1214b. The cooler temperature and unexpected reflectivity challenge existing models and demand a re-evaluation of the planet's atmospheric composition. JWST beyond Neptune. The Webb telescope's observations went even further, hinting at the composition of GJ 1214b's atmosphere. The data suggested a composition lacking a high concentration of hydrogen, indicating that this planet is not simply a smaller version of Neptune. Furthermore, the telescope detected evidence of water vapor and methane. Lead author Elizabeth Kempton expressed confidence in the presence of water on the planet, though she clarified that the extreme temperatures rule out the possibility of liquid water. Kempton emphasized the importance of directing the James Webb telescope towards more planets in this size range. This will help determine whether GJ 1214b is an anomaly or a representative example of its planetary class. The new findings captured the attention of Laura Kreidberg, a planetary researcher at the Max Planck Institute for Astronomy in Germany, who wasn't directly involved in this study, but has previously observed GJ 1214b using the Hubble Space Telescope. She referred to the planet as a white whale for exoplanet researchers due to the immense difficulty in characterizing it. Kreidberg said it was fantastic to finally see some of the planet's secrets revealed. Kreidberg was surprised by the planet's high reflectivity and stated that scientists would need to completely rethink their understanding of what makes the planet so shiny. She went on to say that based on the observations, GJ 1214b might be an entirely new type of planet altogether. Kreidberg mentioned that GJ 1214b shares more similarities with Neptune than Earth, but it ultimately remains a unique entity. She explained that Neptune's atmosphere is primarily hydrogen, whereas GJ 1214b's might be dominated by water. Kreidberg noted that these findings push the planet into a whole new category, something we weren't entirely sure existed before. She concluded by expressing surprise at the absence of such planets in our solar system, considering their apparent prevalence elsewhere in the galaxy. Outro. Neptune's hidden depths have only just begun to be revealed. This discovery shows that there's so much more to learn about our solar system and beyond. The faint band of clouds suggests atmospheric circulation on a scale we haven't fully grasped. and the possibility of a water-rich atmosphere on GJ 1214b, a mini Neptune, opens doors to entirely new planetary classifications. Thanks to the James Webb Space Telescope, we're seeing this icy giant in a whole new light. What other secrets lie beneath its mesmerizing blue surface? This is just the beginning. Stay tuned as we explore the latest findings and delve deeper into even more mysteries of Neptune.